Hello everyone and welcome to section 8.5. You just took a quiz over adding, subtracting, and multiplying polynomials. So the name of this section is using the distributive property. But in all reality, what we're really going to do is start this idea of factoring, and specifically starting factoring using the GCF, or the greatest common factor. So I hope all of you have the sheet in front of you to take notes with me. And before we get into the examples, I want to throw a little review, actually just from the quiz, your way. So before we get to numbers 1 and 2, if I gave you this problem, 2x times 2x to the third minus 4x, what we've done is when we distributed the 2x into the problem, we have multiplied the numbers and got 4. We have added the exponents and got x to the fourth minus 8x to the second. So doing the distributive property forwards, we multiply the numbers and we add the exponents. However, this video is almost opposite in every way. What we're going to be doing instead of doing the distributive property forwards is looking at a problem like number 1 and taking out the greatest common factor. So we're going to go from a problem that looks like it has no parentheses to making it look like something in the red. So what I want you to do with me is look at number 1. And we have 3 terms, or a trinomial. Is there any number, 2, 4, or 16? What is the biggest number that I can take out of 2, negative 4, and 16? If you're thinking 2, I agree with you completely. Now, here's the annoying part. This term has an x squared, this term has an x, and this one does not have any x at all. So am I allowed to take out any x's if all 3 terms do not have x's? The answer is no. So the only thing I can take out is a 2. And so what we do is we leave the 2 in front, and then we think division and ask ourselves what's left over. Because again, these problems are literally the opposite of this idea. So instead of multiplying the numbers and adding the exponents, what we're going to do in these problems is divide the numbers and subtract the exponents. So in this example, if I take a 2 out of 2x, 2 divided by 2 gets me 1x squared. 2 into negative 4, or divided, is minus 2x. 2 into 16 is 8. So this would be my answer when I take out the greatest common factor of 2. The second example, if I look at the numbers 12, negative 6, and 9, the biggest number that goes into all 3 is positive 3. And then if I look at y to the third, y squared, and y, I ask myself, what is the biggest exponent that I am allowed to take out of all 3? First, my eye goes to y to the third, and I ask myself, can I take 3 y's out of 2 y's? Well, no, because if I don't have 3 y's here, I can't possibly take out 3. Can I take 3 y's out of 1 y? No. So, funny enough, a pattern starts existing that you're going to take out the lowest power. So in this case, the lowest power that I see is just y to the first. So if I took 3y out of every single term, think division with the numbers. 3 out of 12 is 4. And with the exponents, think subtraction. 1y out of 3 y's is 2 left. If I take 3 out of negative 6, I'm left with minus 2. If I take 1y out of 2, I'm left with 1. If I take 3 out of 9, I'm left with 3. If I take y out of y, there's no y's left over, so I just close my parenthesis there. So before we move on to other problems, again, think about this is completely opposite of what we did above here. The completely opposite of this. We are dividing the numbers, and we are subtracting the exponents. And a common idea is that when you're looking at the variables, you again want to pick the lowest power. So if we use this idea onward, let me scroll down actually to number 3. If we look at number 3, I notice we have r's and t's this time. And just like number 1, please be careful that if you do not have a certain type of variable in each term, you cannot take it out. So if we look at number 3, what is the biggest number I can take out of 6 and 3? Well, that is 3. If I have r squared here and just a single r here, how many r's am I allowed to take out without going over? Well, you want to take the smaller exponent. So you want to take one r out, and here I have a t and a t squared. So again, I'm going to take out a single t, or the lowest exponent. And so now if I think division and subtraction, if I take 3 out of 6, I'm left with 2. If I take 1 r out of 2, I'm left with just r. If I take t out of t, that's gone. Minus. 3 out of 3 is technically 1. R out of r is gone. T out of t squared is just t. So you either could write your answer like this, or you could write it as 3rt, 2r minus t. Either answer works. So what you're doing is taking the greatest common factor out, and in the parentheses, you're writing what is left over. 75 and 60, and I ask what is the biggest number I can take out of both. If you're thinking 5, I agree with you somewhat, but actually a bigger number that goes into both is 15. Then I look at the b's. I have b squared here and a single b here, so I take out this lower exponent of b. If I have 3 g's here and 3 g's here, am I allowed to take 3 g's out of 3 g's? Yes, that's definitely possible. So I'm going to take a g to the third out as well. So in the parentheses is what's left over. 15 goes into 75 5 times. B, if there's 1b being taken out of 2, there's 1b left. If I take g cubed out of a g cubed, that's gone. So I write plus. 15 goes into 60 4 times. B goes into b itself once, so the b's are also gone if you think b divided by b. And then g cubed, if I take g cubed out of g cubed, that is also gone. So both of these have been taken out, so I'm just left with 5b plus 4. So this is taking out my greatest common factor. Number 4, if I take a look at this one, when I look at 32a squared plus 24b squared, I notice that the only thing that these two terms have in common is the numbers. I can't take an a out because they both don't have an a, and I can't take a b out because they both don't have a b. So each term needs each letter, or each base, to take it out. The biggest number that goes into 32 and 24 is 8. And so I can only take an 8 out. 8 goes into 32, think division, 4 times, a squared's just still there, plus 8 goes into 24, 3 times, b squared is still attached on. So for number 4, we could only take out a single number. Number 5, when I look at 30 and 35, the greatest common factor is 5 with the numbers. I look at x cubed and x squared. The smaller of the exponents is x squared, so I take that out because I'm allowed to take 2 out of 3, but I can't take 3 out of 2. I look at y and y squared and take out the smaller exponent of y. So I now do division and subtraction of exponents. 5 goes into 30 6 times. X squared, if there's 2 x's here and 3 here, I'm left with 1. If I take 1 y out of a y, that's gone. 5 out of 35 is 7. X squared out of x squared is gone. Y out of y squared gives me a single y left over. So this would be my answer for 5. And so again, it really is the distributive property backwards, because you created something that did not have a parenthesis to creating something that looks like the distributive property originally. Okay. Number 6, and I'm just doing these 2 examples, and I'm going to give you some to try. Number 6, when I look at this trinomial, I notice that 9, 18, and 24 does have a greatest common factor. The biggest number I can take out of all 3 would be, actually, I believe, the number 3. I notice that this term is the only one with an a, so I can't take an a out because it's not common. I notice that this term only has a b, and these 2 don't, and this term has a c, and these 2 don't. So I can't take out any a's, b's, or c's. But I do notice that there's an x cubed, an x squared, and an x. The smallest exponent between those 3 is just x, so I can take out a 3x and then go through the motions. 3 goes into 9 3 times. X well, 3a, because a, you didn't take the a out. If you take 1x out of 3, you're left with x squared, plus 3 out of 18 is 6. X out of x squared leaves you with an x, but again, that b is still there along for the ride. 3 goes into 24 8 times. The c is still there, but if I take an x out of x, the x is gone. So this would be my greatest common factor here. And number 7, switch up the color. If I look at this term, and this term, what is the biggest number I can take out of 8, 24, and 16? Well, that is actually the number 8 itself. When I look at p squared, p, and p, the smallest exponent is just singular p. If I look at r squared, r to the third, and r, the smallest exponent is r. So if I take 8 out of 8, I'm left with 1 technically. P out of p squared, I'm left with 1p. R out of r squared, I'm left with r, minus 8 into 24 is 3. P out of p is gone. R out of r cubed is 2 r's, or r squared, plus 8 into 16 is 2. P goes into p once, and that's gone. R goes into r, and that's gone also. So this would be my answer for number 7. So what I would highly, highly encourage you to do is flip your notes over, and I would like you to try extra examples that I'm going to write on here on the back of your paper. Okay? So if you could flip your notes over, please, to the blank side. Here are 3 problems that I want you to write down, and I want you to try, and I will come back with the answers in a little bit. Number 1, I would like you to take the greatest common factor out of 9x to the third minus 27x plus 18. Number 2, I would like you to take the greatest common factor out of 20x to the second y to the fifth plus 15x y to the seventh. And number 3, I would like you to take the greatest common factor out of 4x to the third y to the sixth minus 2x y squared plus 6x to the fifth y to the fifth. So after you're done copying, please pause your video now. Please try all 3 of these on your own, and I will come back with my work so you can check it with me. Thanks, and please pause now. All right, guys, so to go through these, number 1, I said that my only greatest common factor was 9 because all 3 terms did not have an x, so I could not take that out. So when I divided everything by 9, I had 1x to the third left over minus 3x plus 2. You could have written your answer this way, or you could have not had the 1 and written it this way. So please check in that. If you have any questions, please call myself or Mr. Foster over. Number 2, I noticed that the biggest number that you can take out of 20 and 15 is 5. I looked at x squared and x and took out a singular x because it's the lower exponent. Then I looked at y to the fifth and y to the seventh and took out the lower exponent of 5. And then I did some division and subtraction. 5 goes into 20 4 times. X goes into x squared, and there's 1 left. Y to the fifth out of y to the fifth is gone. Plus 5 goes into 15 3 times. X into x is gone. Y to the fifth into y to the seventh is that there's 2 y's left. So this was my final answer for 2. And 3, the biggest number I could take out was 2. I looked at my x's, x to the third, x, and x to the fifth, took out the lowest exponent of x, y to the sixth, y squared, y to the fifth, took out the lowest exponent of squared, and then I did some division. 2 goes into 4 2 times. X goes into x cubed. There's 2 left over. If I take 2 y's out of 6, I'm left with 4. This was a tricky part here. If you take 2 out of 2, you're technically left with 1, but then the x and the y squared both kind of dropped out. So I was just left with minus 1, plus 2 goes into 6 3 times. X goes into x to the fifth. There's 4 left over. Then y squared goes in the y to the fifth 3 times. All right, guys, if you have any follow-up questions, please, again, feel free to call me over. Have a great weekend. Thanks.